Okay, for the rest of this target, we have a lot of things to talk about when it comes to the graph of parabolas and quadratics. So one question to ask is, where are the x-intercepts when we look at the graph? And if you don't remember what an x-intercept was, you maybe talked about this when you looked at just lines last year, just a line of a function that goes like this. An x-intercept is where the function crosses the x-axis. And the x-axis is the horizontal axis, the one that goes left and right. It's not the one that goes up and down, it's the y-axis. The x-axis is the one that goes left and right, it's horizontal. So let's look at the last example that we had, right? We want to know what are the x-intercepts of the quadratic x squared plus 9x plus 20. So remember, we want to know what are the points where the function crosses the x-axis. So let's go back and look at our Desmos. Right, here is that function. I want to know where it crosses the x-axis. Well, remember, the x-axis is this horizontal line here. It's this one where x is 0, or where y is 0, sorry. And it actually gives us these points right here. Actually kind of highlights them for us. So let's just click on it. There's, I can click anywhere on it, right? But it tells you like, hey, look, these are important points. So we have two. We have -5, 0, and then -4, 0. So let me go ahead and write those out. -4, 0, and -5, 0. Okay, something to kind of notice here, and I didn't write this in the notes here, but I think this is important to notice. The rule is the y value is always 0. And if you don't know which one's the y value, it's always the second one. Think of your alphabet, right? When you start getting to the x, y, z, right? X comes before y. So when you write your point, x goes first. So the y value is always 0 because it's going to have no up or down, right? It's just going to be on the x-axis. So it's not going to go up any, it's not going to go down any. So the y value is just 0. It goes up 0, goes down 0. Now, there are some other instances that are kind of important to talk about with x-intercepts. There's possibilities, right? You're either going to have 2, 1, or 0. And I'm going to show you examples of each of these. So this is an example of 2, right? We have 2 x-intercepts. So here we have x squared plus 4x plus 4. This has one x-intercept. And notice it's also the vertex. So it only crosses it at one point. It just touches it right there. This is a special case of scenarios. You will not see this super often, but it's worth mentioning. There's one final scenario where there's 0 x-intercepts. The function never crosses the x-axis. It's an example like x squared plus 4 right here. There's not even a middle value. There's no plus x at all. It's just completely skipped. So here we don't even cross this line here. We just have a vertex. We just have that right there. There's nothing else here. There's no crossing this line. So there are 0 x-intercepts. Make sure when you identify the x-intercepts, you write them as points. Very important to do so because they are representing a location, and we do represent locations with points.